So I'm going to go ahead and get the presentation started here. Let's see. So 1 second. There we go. So making modern electronics at home. So basically, I just want to talk about the experience I've had in the last couple of years making electronics and custom boards in particular. So let's see, here's the contact information. So basically 2 years ago, I had some cool ideas for a new type of smart pen that was kind of a synthesizer smart pen. And there's no hobby board that really did what I wanted. So I decided to come up with a custom board, but I kind of went through the 3 phases of starting with these hobby boards like Arduino. And then I moved on to more custom prototype boards. And then after that, I decided to go to like a full custom surface mount assembled board. And so I'm going to show you some pictures of the different steps of that I took through this process. So here's some, you've seen Arduino boards before, so I'm not going to show you that, but here are some prototype boards that I made a couple years ago. And basically with the prototype board, you start with just a blank board with a bunch of holes on it, kind of like a breadboard. And you break it to whatever size you want. And you just solder through hole components into it. And you can see there's some chips in there. There's some modules. And it's pretty basic, pretty easy to put a couple of these together, but you wouldn't want to put more than 2 or 3 of these together. It kind of drives you insane doing it. So those are 2 different boards. And then here's the back of those same boards. You can see soldering all these wires in is not easy, and especially in the top one here. These are very tiny wires, 30 gauge wires. And so it's very time consuming and error prone to do all that. So kind of after I went through this phase of building these proto boards, I moved on and realized that I really should just make a custom printed circuit board and assemble it. And so why would you want to do that is I have some reasons here. Number one, you have a huge variety of parts, huge selection of parts. With the hobby boards and shield boards, you have a very limited number of parts you can use. So if you go on DigiKey or any component supplier, you'll find they probably have 100 million or 100, I don't know how many millions of parts, different parts, but they have pretty much anything you could think of. And the other reason is it's very easy to assemble a surface mount board. You might not think so, but if you have the right tools and there's only a couple tools you really need, it's actually really easy to assemble surface mount boards. Another reason is with the hobby boards, it's not really a finished project. It's not something you could sell, and it's not manufacturable. Proto boards particularly, you can't make many of them. So, and the last reason, for the challenge, it's always more difficult to make a custom board, but it's more of a challenge. So I'll show you some of my custom boards. So you can see here on the left is one of my more recent boards. It's a Bluetooth microcontroller with a audio DAC on the same board, and then some headers to connect to sensors. So this is the board I'm currently working with. and it's working really well. These packages are pretty small. They're called QFN packages. The connections are mostly on the bottom of them, so that makes it difficult to impossible to solder with a soldering iron. Pretty much need a reflow oven to do this. Over on the top right is the Smart Pen board that I developed, and it's also a Bluetooth microcontroller and some light sensors and stuff. And it fits inside a pen, so it's very small. And it has 2 wires going off to the battery. And the one on the bottom right is a more recent board I made, just has a single sensor on it, and it plugs into the other board on the left. The thing about this board is the sensor is very small, much smaller than any of the other chips I've dealt with. So it's very difficult to get it soldered correctly. So in terms of tools, you really only need 3 tools to assemble custom circuit boards. Might be a little surprising, but with these 3 tools and the actual board and some solder paste and a stencil, you can assemble your own board. So for the microscope, you want an inspection microscope, which is on the stand here like this. You only need 10 to 20 times magnification. Anything more than that's not really useful for electronics. And these are pretty cheap on Amazon. For the reflow oven, they're more expensive, but you can buy these really cheap Chinese ones, and they require a little bit of modification, but nothing drastic. And what a reflow oven does is it controls the temperature over the course of about 8 minutes. And it raises the temperature to a fixed amount, and then for a certain amount of time, maybe 2 minutes, and then raises it even further and then drops it back down. And that allows the solder to melt at the correct temperature and the correct rate to connect to all the components. So that's a critical one. All 3 of these are critical tools. But and then the suction tool is, I just made one out of an aquarium pump and some plastic tubing and like a non-surgical needle. And basically what suction tool, I use that to pick up components. Tweezers are in most cases too big and too clumsy to really pick up small surface mount components. You can use tweezers, but one of the problems I've found is if you don't grab a component just right, the tweezers clamp shut and the part flies off into oblivion. And if it's an expensive part, then that's unfortunate, So with the suction tool, you just basically place the tip over the component and you can lift it up without having to grab it from the sides. All right. So there's about 4 steps that I'm not going to go into detail about these steps, but I'm just going to give you an outline of the steps involved. So first step, you want to choose your parts. So your microcontrollers, your sensors, the main parts. And you'll definitely want to go through the data sheet. So every manufacturer of electronic parts makes data sheets, and they tell you exactly how to use the component and all sorts of important information. And if you're going to go beyond very basic level electronics projects and stuff, you want to get familiar with data sheets. So you also want to check the prices and availability of the parts. A lot of manufacturers will sell it's called development kit, which is their processor or their part on a board as like a demo board made just for their chip. and it demonstrates the software and the whole system. And that's very useful for getting up to speed with a new part, for example. And also, if you get the development kit, or even if you don't, you should download the software tools for developing software for a microcontroller. Yeah, you might find a really good microcontroller that you like, but if the software tools are a pain in the ass, then you might decide to use a different one. So I've done that before. For voltage requirements, you want to look at your voltage regulators to make sure that all your components are at the same voltage, or if you need separate voltage regulators, you need to take a look at that. So for step 2, now you're going to design the circuit in a CAD program like Eagle or KiCad. I use KiCad, works well. So I put in here read data sheet again. So the data sheet is going to give you example circuits. The data sheet is central if you're going to try to assemble or put together your own circuits. Go back to the data sheet, look for typical applications. Like this one over here, this is a voltage regulator. And they basically tell you how to hook the thing up, what the capacitor values and the type of capacitors. They give you all the answers to the problem, the design problem. So try to use everything they give you, and just change as little as possible, because they kind of give you the optimized circuit for their chip, whatever it is. You also want to download the symbols and footprints. So every electronics component has a CAD symbol and a corresponding footprint. And the footprint is just, it's important actually. It's the parts of the circuit board that connect to the circuit or to the component. So it's the little squares on a circuit board of metal, the contacts where they make contact with the components. So usually you'll download those together from some websites have them, or you have to create your own in a footprint editor. Also, some manufacturers will give you design files. So that basically gives you the schematics of the example boards or the schematics they just provide you with. So also you want to take advantage of forums and contact the manufacturer. A lot of times they'll respond to your questions, and ask your friends in the electronics club. So step 3, you want to design the circuit board. And again, I say, hey, I have here, read the data sheet, because a lot of times they give you a layout, circuit board layout. Not too frequently, but sometimes they'll give you an example of how to lay out certain parts of the component, the circuit. So you'll want to do a lot of research too when you start designing printed circuit boards. You want to read about ground planes, layout, stencils, connectors, many different things before you really dive into designing the circuit board. So I'm not even going to try to explain all that. But then you go to a website and get it. You basically send them your design files, and they'll manufacture it for you. And it's not too expensive, really. You can get 5 boards made for $5 or $10. And you pay more for shipping just to get it sent to you from China. So, and odds are you'll mess some up. So practice makes perfect. All right, step 4. So once you have all these parts and the board, it's time to assemble it. So it's best, I've found, to organize all your parts ahead of time. I lay all my parts out on like a piece of cardboard. Over here, you can see I use double-sided tape to stick down all these strips. Each strip is one component. And then I label it. When it's on this piece of cardboard, it's I use kind of a thick piece of cardboard so it doesn't move around a lot, but I can rotate it, which is very useful if I need to pick up a component in either orientation. So when you buy the circuit board, you also buy a stencil, which is basically just a sheet of thin metal with holes cut out where the solder paste needs to go, where the components will be. So if you've ever done like a t-shirt screen printing, it's the same thing. You just lay the stencil over the circuit board, line it up real carefully, and then put solder paste on one side and squeegee it across. And then you remove the stencil, and there you'll have solder in just the right places. And if it's a little off, you can just wipe off the solder paste with some alcohol and try again. So then you place all the components. This is where the suction tool comes in. So you'll go over to your component tray and pull back the little plastic tape and use the suction tool to pick up a component and then drop it down very carefully. Also, the microscope is critical here because the components need to be positioned just correctly. And then last step is just put it in the oven and cook it. That step is very easy. So yeah, I just wanted to mention that the package sizes on these chips are getting smaller and smaller. Last year, I figured out how to do these QFN packages to get them soldered correctly. And they're very, like 5 millimeters by 5 millimeters. But then just this year, I was able to get these tiny sensors soldered correctly, which is less than a millimeter on a side. So they're just getting smaller and smaller. So about embedded software. So usually it's going to be in C or C++. So you won't be able to use your like Arduino tools or anything. It's going to be a more professional like development environment, like Sager, ARM, Keel, and MPLab are some of the examples. Usually the manufacturer will tell you which one works best for their chip. And you'll probably need to buy a programmer, a hardware programmer. So it's basically just a little USB module that you plug into your board to program it. And you probably want to start simple with LEDs and buttons just to test your board before you do anything more advanced, like sensors and stuff. Now I have a bunch of recommendations here. So you can go through those whenever you want to. I'm not going to read through these, but this is basically just a list of all the particular websites and software and hardware that I've used that works really well. So I think that's about it. Maybe I went through that kind of fast, but my name's Cory. I also, a couple of years ago, did a music notation that you might be, if you're interested in music. This is my music notation called pitch bracket notation. You might be interested in. There's a website, pitchbracket.com. So I think that's about everything I was going to talk about today.
Do you have any like parts or boards you could kind of show us, like kind of the real scale on camera?
Yeah, hold on a sec.
If anyone else has questions, feel free to just unmute yourself or type it into chat.
So here's another board I have. I'll put it up to the camera here. It's basically an array of sensors. And each of these is a little tiny circular board. And this is called a panel. So a panel is a single board with multiple copies of the same board on there. And so it's easier to do a panel when you have one board that you want multiple of. You can save some money by creating a panel instead of just individual boards. I'll show you one other one here. So the one board I was showing, I had an image of earlier, was this tiny board that fits in a pen, microcontroller board. And so one of the difficult parts of programming this board was how can you program a board that doesn't even have space for a header that fits inside a pen? So what I ended up doing was, if you can see on the side of that board, there are contacts. And so somehow I had to connect to those contacts to my programmer hardware. And so I made this weird looking board. Basically, it has these retractable pins here. And what you do is, to program this guy, you wedge it in here. And basically it makes contact with those little contacts. And this is the only reason I did this, was because I didn't have room on the board itself to put a header. And this is an actual technique they use. It's not a totally obscure way of doing it, but sometimes they do this, putting the connections on the edge of the board to program it. It's kind of a weird board that you definitely won't have any kind of boards like that out there already. So yep, that's about everything. Are there any questions?
What does that little pin board do, actually?
So it's basically a Bluetooth microcontroller with a bunch of light sensors. And I built it because I was building an audio synthesizer that fits inside a pen. And basically it detects the light coming in the tip of the pen and produces audio based on basically what it's seeing from the light sensors. So my idea has kind of evolved into something a little different now, but it was definitely a challenge to get it that small to fit inside a pen. So I've learned a lot from just doing that. So, any other questions?
Do they make pick and place machines that you can use at home, or are they all just industrial?
I don't think I don't know of any that are under $1,000 or $7,000. So that's those machines are pretty complicated. I don't think you would be able to. Most hobbyists wouldn't be able to afford one of those machines. Maybe, who knows?
Yeah, that's what I was thinking. I work with some at work. I work over at Avcom,
Okay.
SMT. So I didn't know if they made any that were like more compact, but
Yeah, maybe they do, but I don't know of any. And it's kind of fun using that suction tool. It's a challenge. You have to be very focused, and I usually do it late at night when there's not much noise around me. So. Any other questions? Is anyone considering making custom boards on theirself, or is it not very interesting thing to everybody?
I think
Yeah.
actually we're planning on having a workshop, like if everything comes back to in person next semester, we will have a workshop on actually creating a circuit board and ordering them, and kind of coming back next week and kind of putting them together. So I think that's on the docket for next semester's activities.
Yeah,
Yeah, that'd be cool.
especially like easy EDA, like actually creating PCB, I think would be very neat.
Yeah. Yeah, I do recommend everybody who's interested in electronics try making at least one circuit board, even if you can't assemble it. It's just really interesting learning how to design a circuit board and get it made. And it's really cheap. Like these Chinese companies can make a board for literally like $5. You can have 5 or 10 of them. And then you pay maybe $20 to get it sent to you. But yeah, it's really interesting to learn all the different skills, how to design the circuit, design this board, assemble it. It's very challenging because it's all these different things you have to learn to do to get one board made. You have to learn all these different skills, but it was a lot of fun.
Yeah. Well, give it up for Cory Gledhill. If we can do more clappy reactions.
Yes, thank you.
Thank you so much for presenting to our group today.
Sure.
Yeah.
Thank you.
You're welcome.
I believe our next meeting will be